Hello everybody, this is Mr. McNair, and this is a video on the 2009 OGT questions from the Data Analysis and Probability section. Now, what I would suggest you do is go ahead and pause the video for a moment. Go ahead and read through the tips so that you can use the video most effectively. Alright, let's look at problem number 1. A mother is keeping a record of how her new baby's weight changes as the baby grows. The mother's record is shown in the table. What type of graph should she use to show how the baby's weight changed over time? Alright, first thing that I would recognize in this problem is the phrase changed over time. Anytime you see that phrase changed over time, you're most likely going to be dealing with a line graph. Line graphs always show change in data over time. So automatically, you can look at this problem and say, oh, I know it has to be a line graph. Whoops. I know it has to be a line graph simply because it's asking me to show change in data over time. Okay? Number 4, Leroy has a number cube with size labeled 1 through 6. He tosses the number cube 4 times. Each toss results in a 5. What is the likelihood that the next toss will result in a 5? Well, when we're talking about likelihood, we're also talking about probability. Probability you find by taking the number of favorable outcomes and dividing it by the total number of outcomes. Okay? So the number of favorable outcomes, well, the favorable outcome we're talking about is Leroy rolling a 5. Well, how many 5s are there on this number cube? Well, there's only one of them. Okay? And we're going to divide that by the total number of numbers that are on the cube. And how many numbers are on the cube? Well, there's 6. So the likelihood or the probability that Leroy will roll a 5 is a 1/6 probability. Okay. Number 16, Tanya and her friends earned extra money by mowing lawns around their neighborhood. Tanya created a table to show their earnings. Pedro noticed that Tanya made a mistake. His earnings were $24, not $8. How does this change affect the mean of the group's earnings? Well, the first thing that you should know about this problem is what mean is. Mean is another word for average, and you find the mean or the average of something by adding up all of the entries, or taking the sum of them, and dividing by the total number of entries. So, here, the question asks us to decipher what's the difference between the mean when we have Pedro being $8 and then when we put in the correct amount that Pedro earned, which was 24. So we're going to have to do this mean twice. Alright, so let's do the mean of this data first, the data that we have with the error in there. So we do that by adding up all the entries. So let's add up 34 plus 34 plus 34 plus 25 plus 22 plus 22 plus 17 plus 8, and we get a total of, the sum is 196. And the number of entries that we have, we're going to divide by that. 1, 2, 3, 4, 5, 6, 7, 8. There's a total of 8 entries. 196 divided by 8 is 24.50. So the average, or the mean, is $24.50. Now, we know that Pedro really didn't earn $8. He actually earned $24. So we're going to add these values up again and actually come up with the correct mean. So instead of those values adding up to 196, they're actually going to add up to 212. And then we're still dividing by 8. And that value comes out to be $26.50. So let's go ahead and compare go through our choices here. The mean remains the same. Well, that's not true. The mean increased by $2. That is true. Okay, so there's our answer. Let's go on. Number 22. Local residents have requested a traffic light at the intersection of Polk Road and Vine Street. They claim that the intersection has become unsafe for their children due to the high volume of drivers using these roads as shortcuts during rush hour from 4 p.m. to 6 p.m. In response, the street department installed a device that would count cars going through the intersection. The device counted the total number of cars each day for a 2-week period. The department used the result to determine the average number of cars passing through the intersection each day. They decided the number was normal for an intersection with no light and refused the residents' request. In your answer document, explain how the residents can claim that the method the department used to collect the data does not provide valid information for evaluating their request. Okay, so here, in a problem like this, number one, I would read the problem twice. Just make sure that you understand everything that the problem is stating and everything that the problem is asking. Here, I think that the main problem that you need to address is the fact that the street department collected a sample during the day, the whole day. Okay, but the residents, they had a problem between the times of 4 p.m. to 6 p.m. The street department should have collected the data during rush hour only and compared the volume during that period with other rush hour volumes. Okay, but because they collected through the whole day, well, through the whole day, things could have been really down. The volume of traffic could have been really low at the beginning of the day or even after rush hour. So things might have averaged out because of that. But because they collected it throughout the whole day, we don't exactly know what happened between the time of 4 p.m. and 6 p.m. You could also say the street department sample included weekends, when there's less traffic during rush hour because many people don't go to work. So they shouldn't collect data during the weekends. All right, so all of that are things that you could actually talk about in this problem to verify the resident's request. Okay, let's go on. Number 26. A banquet center offers a choice of 3 salads, 5 main courses, and 4 desserts. How many different meals can be created by selecting 1 salad, 1 main course, and 1 dessert? Well, here there's a couple ways you can do the problem. One way that I'm not going to show you is actually to make a tree diagram. Where you could, say, okay, well, there's 3 salads, actually draw those out, and then from those draw 5 main courses, and from that draw 4 desserts. Easiest way to do this problem is actually what we call the counting principle. And the counting principle says that you could find out how many combinations you could actually have by multiplying all of the number of choices together. So here we know that there are 3 possible choices for salads, by 5 possible choices for the main course, and times that by 4 possible choices for the desserts. So that multiplies out, when you multiply those 3 numbers, to a total of 60. So there are 60 possible different meals that you could do. Okay? All right, number 31. The bar graph shows the number of customers in Rio's restaurant each day last week. What is the approximate mean number of customers per day in Rio's restaurant last week? Once again, we find mean by taking the sum, adding up all of the entries, and dividing by the number of entries you have. Number of entries. Okay, so here you actually have to find the sum by interpreting it from the bar graph. So let's look at Sunday. Sunday we have a little bit above 800. So let's say that we have 810. Okay, and it's okay to approximate. Okay, it's okay to approximate here. Monday we have right here. It looks like it's somewhere between 300 and 400. So let's go ahead and do 350. Tuesday, it looks like it's exactly at a 400. Wednesday, it looks like it's at 350 again. Thursday, looks like we're a little below 300. I'm going to go ahead and say that we're at like 280 or something. Okay. Friday, we're a little above 400, so let's go 410. And Saturday, we are a little below 900, so let's say about 890. Okay, so now once again we're going to add these all up and find the sum. So 810 plus 350 plus 400 plus 350 plus 280 plus 410 plus 890. That adds up to be 3,490. And we're dividing this by the number of entries. Well, how many days are we dealing with here? We're dealing with 7 days, 7 days in the week. So 3,490 divided by 7 is 498.5. 0.57, so we'll write to 0.6. So here, what is the approximate mean number of customers per day in Rio's restaurant last week? Well, it's closest to 498.6. So which one is that closer to? D, 500. Okay, so number 31 should be D. All right, number 35. A town census was conducted every year for the past 10 years. The scatter plot below shows the result of the census. If the linear trend continues, which prediction is supported by the data? Well, one thing that you should notice in this data is that the trend is like the line of best fit. It's the line that goes through the middle of the data. All right, and here the line is going up. Okay, so we know that the population is increasing. So let's go through our choices and eliminate the ones that don't make sense. So A, the population will stay the same for the next 5 years. Well, no, our population is going up, so we can cancel that out. The population will reach 120,000 within the next 10 years. Well, let's look. What happened in 10 years here? In 10 years here, we went from about 10,000 to about, let's say, about 4,200 or 4,500, somewhere in there. So there is probably an increase of around a little over 30,000 here. Okay, now if there's an increase of about 30,000, and right now we're at about 45,000, well, at the most in the next 10 years we're probably going to be at somewhere at about 75,000. So we can't say for sure that in the next 10 years we're going to reach 120,000. C, the population will decline steadily over the next 10 years. Well, once again, we're going up. Decline means to go down, so that's not what we're doing. And D, the population will exceed 50,000 people within the next 5 years. Well, we're actually pretty close to 50,000 already. So even as looking at this line that I've already drawn, it already looks like it'll reach about 50,000 within the next couple of years. So will it exceed 50,000 people within the next 5 years? Yes, it will. So number 35 is D. All right, number 38. The areas in square miles of the Great Lakes are shown in the bar graph. Based on this graph, which set of numbers is the closest to the total area of the 5 Great Lakes? So let's take a look at these. We're just going to estimate once again. So this here, Lake Superior, is a little bit above 30,000. So let's say that it's about 31,000. Okay, let's look at Lake Michigan. Lake Michigan is a little above 20,000. Looks a little bit more above it than Lake Superior was above that line. So we'll go 22,000 there. Lake Huron. Lake Huron is a little bit above Lake Michigan. So let's say it's about 23,000. Lake Erie. Lake Erie is like right at the line. Let's just go ahead and put that at 10,000. And Lake Ontario is below the line, so we're going to go ahead and put that at about 7,000. Okay, so let's go ahead and add those all up. So 31,000 plus 22,000 plus 23,000 plus 10,000 plus 7,000. And I got a total of 93,000. So let's look at our choices. Based on this graph, which set of numbers is the closest to the total area of the 5 Great Lakes? Did we get between 70 and 80,000? No. Did we get between 80 and 90,000? No. Did we get between 90,000 and 100,000? Yes, we did. Okay, so our answer for number 38 is C. All right, last problem, number 42. Population data for Ohio is provided in the table below. Based on the data, what is the probability rounded to the nearest 10,000th that a male selected at random in Ohio in 1998 would have been Hispanic? Okay, So here, again, probability is going to be the number of favorable outcomes divided by the total number of outcomes. Okay, so let me erase that here. So here we're trying to figure out what is the probability that a male selected in Ohio at random would be Hispanic. So here we're only really worried about the males. We're not worried about the females or the total. So those pieces of data are not necessary. Okay, so what we want to do is find out, well, Hispanic, that's the one that we're looking for. So that's the favorable outcome here. So that's 76,660, and we're dividing that by the total number of outcomes. Well, the total number of men in Ohio at that time is 5,215,573. Okay, so we're going to take that value and we're going to divide that in our calculator. So let me go ahead and pull up the calculator real quick. All right, so 76,660 divided by 5,215,573. The value we get out is there. So this is our answer. Okay, so this is the value that we're dealing with. Now, the question says that they want us to round to the nearest 10,000th, Okay, so when you're rounding to the nearest 10,000, you need to know your places. Here, this is the tenths, hundredths, thousandths, 10,000ths. Okay, so the place that we're dealing with is this place right here. And when you're deciding whether or not to round up or stay the same, you look to the value to the right. All right, so because this value is 5 or higher, we round up. So we're going to go to 0.0147. Okay, if it was 4 or lower, we would have just kept it at 0.146. So the answer here is C. Okay, I hope this video is helpful to you, and good luck studying for your OGT.